RHS Pre-Calculus presents Hyperbola for Dummies.
Many people have trouble with hyperbolas and their graphs. After seeing this video, you should be able to understand all the components of hyperbola: the center, the foci, the asymptotes, and the vertices.
Okay. Now, as shown in the example, the basic equation for a vertical hyperbola is negative x minus h squared over a squared plus y minus k squared over b squared equals 1, where hk is the center of the graph, as shown here. A is the horizontal distance from the hyperbola's center, and b is the vertical distance. Another variable, c, not visible in the equation, can be found by the equation c squared equals a squared plus b squared, which represents the distance of the foci from the center of the hyperbola, shown here and here. The asymptotes are also important when graphing the hyperbola, and their slope can be found using the equation plus or minus b over a. Asymptotes are important when graphing the hyperbola because they help show the general shape of the hyperbola. Vertices for a vertical hyperbola, are h, k plus or minus b. They are shown here and here. They are similar to the vertex of a parabola and are the points that come closest to the center of the hyperbola. Now, given the equation negative x plus 1 squared over square root of 3 squared plus y squared over 2 squared, the center of the hyperbola will be hk. Let's find this now. H is shown here and will be negative 1 because it is the opposite of what is subtracted from x. K is the opposite of what is subtracted from y, or 0. Therefore, the center equals negative 1, 0. On the graph, this will be right here. To find a and b, we take the square root of what is on the bottom of each equation. For a, this will be the square root of 3. For b, this will be 2. Using a and b and the c squared equals a squared plus b squared equation, we can find both a, b, and c. Now we solve this equation, and c equals the square root of 7, or approximately 2.6. Using this, we can find the foci, vertices, and the asymptotes, which will complete the graph. The foci equal h, k, plus or minus c. This is shown by negative 1, 0, plus or minus c, or the square root of 7. These are approximately here at 2.6 and here at negative 2.6. The vertices will be at negative 1, 0, plus or minus b, or 2. This can be shown here at 2 and here at negative 2. The asymptotes are negative b over, or positive b over a, or plus or minus the square root of 3 over 2. This can be shown by the asymptotes here. Now, all that is left to do is fill in the hyperbola with all the parts of the graph. You come close and touch the vertice, which is the closest point to the center. Now let's see a real-life application from Blair.
For more practical applications, the hyperbola can be used to calculate how spacecraft use a slingshot effect to make a 180-degree turn around a celestial body without the need to reverse using thrusters, and minimizing fuel usage, as thruster burns are limited in space without refueling stations.
This can be shown through the use of a UFO swinging around a planet, passing through the vertex and coming across.
Notice how it never touches the center or the asymptotes.